other day we discussed the polythene bags, right? We discussed that we use polythene bags for the shopping purposes, right? Okay. So polythene is basically a polymer of ethene. Okay. Okay. What is the formula for ethene? C2H4. Correct. So how do we draw it? We draw it accordingly, like CH2 double bond CH2. Okay, when we discuss the reaction of alkenes, I've told you that how this double bond would convert into a single bond. So there would be the electrons that would be sharing, would be taken up by these, and this would be converted to a single bond. Simple. Okay, so in addition polymers, what would happen? These these one bonds would be shared over here with other units of ethene. So this unit of ethene would be repeated multiple times. Again, we would have ethene over here and here, here and here. Similar would be here. A unit of ethene would be repeated many times. And the single unit is known as monomer. Yeah, mono means single, mer mean unit. Poly mean many, and mer mean unit. So many units of ethene. A polymer means many units. Basically, the monomers are repeated. Okay? Okay, what would be the polymer of propene? Polypropene. Okay, can you make a polypropene? It will be CH3, CH double bond, CH2. Let me make it. Okay, now you have to show the repeating units. Okay, wait. Propene. That's propene. I want you to make a like a monomer. How the what change would be there in the monomer? Okay, make it. Now I want to see how are you going to make it. So let's make it. Okay. Okay. So there would be change in the carbons that have the double bond. Okay. So this carbon is going to have a change and this carbon is going to have a change, right? Okay. So we are writing CH2 with H here. Let me just make an expanded form of the structure. Okay. This would be repeated. Okay. And this would be there in a polymerization, this bond. Okay. Here we have another bond which would be included in polymerization. Okay. So this CH3 would be here as a, you can say, a chain, like a branch, not a chain, a branch. Okay. So this won't be taking part. This one is not going to take part in polymerization. So this would be present in the bottom, or you can make it over here. Okay. But it should be present as a branch now. So keep in mind, while making a polymer, the carbons that have the double bond would definitely be part of polymer. If it's CH4, let's say, if it's CH3, CH3, C double bond, CH2, how would a polymer would look like? So there would be change in this one and this one. This would be here or here, right? And this would be repeated multiple times. Okay, and this would now become a branch. Sorry, I have to write 2 here. CH2 and CH3. Okay, are you getting my point? So whatever is present in a longer chain would become a branch, and a double bond would be repeated multiple times. Okay. Um, the next one is polymer that we use extensively. It's PVC. Have you ever heard of PVC pipes? Okay. So let's talk about PVC. Okay. It's called polyvinyl chloride. So polyvinyl chloride is nothing. It's simple. It's basically what do we call it? Ethylene chloride, not ethyl chloride. It's a double bond, and it's ethylene chloride means a double bond present with a chlorine. It's ethene with chlorine. Okay, can you make the structure instead of imagine like let instead of me writing it for you? Can you make a structure? Okay. It's it's vinyl chloride is ethylene chloride, ethene with chlorine. Ethene with chlorine. Yes. So we call it ethylene chloride. So it would be. Have you made the structure? Okay. Yes. No, not yet. Okay, got it. Yes, got it now. Okay, wait, I've told you. Okay, this is ethylene, like ethene. So you have missed the double bond. Okay? Okay, okay. Then you have to put it in a bracket. Okay? With extended forms, like the two bonds would be coming out of the carbons, as the other there should be another bonds. So H, H, and Cl, and here you have to write N. Okay. Okay, so I guess you have got this. Okay, this is all about the addition polymers. Okay, there is one more thing. Okay, how, okay, because these are like non, you can say biodegradable, so they can be a cause of pollution, right? Because we always say that plastics can cause the pollution, right? Why do you think so? Like if we dispose of them in the water, what will happen? Yeah. So what would happen in a longer term? Whatever you're saying is correct, but I want you to like explain it a bit more. So maybe the fish can ingest it. It can clog its like the gills of fish, leading to the uh, death of aquatic life, right? Okay. So how do we dispose them then? How can we? Okay, number one, we can burn them, but that would have exactly that would have an other bad effect. What would be that bad effect? That it would it because we discussed that in the very start that when we burn the organic compounds or the combustion of organic compounds always lead to the production of carbon dioxide and water. So carbon dioxide is going to increase the temperature of the earth, right? It would contribute to the greenhouse gas and would result in global warming. Okay. Second thing, like we have discussed the polyvinyl chloride, PVCs. PVCs, since they contain chloride, they can release a toxic gas, that is hydrogen chloride, basically the acidic gas, which can be harmful for our health. And if there is incomplete combustion, there might be production of carbon monoxide, which is more toxic than any other gas. Like the change or the binding with hemoglobin is irreversible. Okay, what if we dispose them off in landfills? Land pollution. Okay, that's why. Okay, land pollution means they just take the place, whatever the empty space, or whenever you dig it up, it would be still there. Okay, so there is ban now worldwide. Uh, the associations are putting bans on the use of these polymers, which are non-biodegradable. Okay, to reduce the pollution. That's why there is a ban on many places. I hope it's banned at your place as well. It's banned because nowadays paper bags are more in use as compared to the polythene bags, right?